Good morning, students. How are you all? Fine. Okay. So, students, today our topic is ionization enthalpy. In previous class, we have discussed about the atomic size, and today we will discuss about the ionization enthalpy. So, what do you mean by the ionization enthalpy? Ionization enthalpy of an element can be defined as amount of the energy required to remove an electron from an isolated gaseous atom into the gaseous state. Means the amount of energy which is required for removal of the electron from outermost shell of an element. That energy is known as the ionization enthalpy. For example, if we have sodium, so atomic number of sodium is 11. So what will be the electronic configuration for this? Electronic configuration will be 281. Okay. So we want to remove one electron from its outermost shell. You know very well there are three shells. This is nucleus, first shell, second shell, and nucleus, first shell, in first shell there are 2 electrons only. In second shell there are 8 electrons. And in third cell there are 1 electron. So we want to remove this electron, the outermost shell. Outermost shell means the cell which is present in outer. That is known as the outermost shell or valence shell also. So if we want to remove this electron, so we need to provide some energy. And that amount of energy which is required for removal the electron from outermost shell, that is known as the ionization enthalpy. Ionization enthalpy. So we will give some amount of energy, then it will release the electron. After removal of the electron, it convert into the Na positive plus electron. How many electrons? It is going to remove 1. Okay. So the amount of energy which is required for removal of the electron from outermost shell, that is known as the ionization enthalpy. It is clear to you or not? Yes. So students, ionization enthalpy depends on the following factors. There are some factors on which ionization enthalpy depends. So factors are the penetration effect, shielding effect, and electronic configuration. So we will discuss one by one these factors. What do you mean by penetration effect? What is shielding effect? And what will be the effect of the electronic configuration on ionization enthalpy? So first one is the penetration effect. Penetration means the proximity. What do you mean by the proximity? Proximity means closeness. Closeness, near. Penetration means the proximity of an electron in an orbital to the nucleus. Means how much close, how much near the electron is present to the nucleus. That is known as the penetration effect. That is known as the penetration effect. Okay. So for each shell and subshell, it can be observed as the relative density of electron near the nucleus of an atom. Means if electrons are present near the nucleus, okay, so what is the density? How much dense they are? How much? The electrons which are nearly towards the nucleus, their density will be higher. Their density will be higher. Okay. Now if we look into the radial probability distribution functions, we see that the electron density of s orbital is closer than p and d orbital. You know very well, the electron of the s orbitals are nearly present to the nucleus. They are close to the nucleus. Then they will show the more penetration effect. Then they will show the more penetration effect. So what will be the order of the penetration effect? The order will be the 2s, then 2p, 3s, 3p, 4s and 3d. Means if we want to discuss about the configuration of sodium or other element, we can take also. Okay. So here its atomic number is 11. So what is the configuration? 1s2, 2s2, 2p6 and 3s1. So here this orbital, this subshell will be close to the nucleus. It will be the nearest to the nucleus. So it will show the more penetration effect as compared to this. And it will show more penetration effect as compared to this. So what is the penetration effect? Penetration effect is the proximity of the electron in an orbital to the nucleus. This effect is clear to you or not? Yes. Yes. So second one factor is the means if penetration effect increases, then their ionization enthalpy also increases. Then second one factor is the shielding effect. What do you mean by the shielding effect? Shielding effect can be defined as the effect in which the inner electrons develop a shield for the electrons in outer shells, which does not let the appropriate nuclear charge towards the outermost electron. Due to this, the outermost electrons experience a low effective charge and not the actual nuclear charge. What do you mean by this, students? If I talk about an element which have more number of the shells. So you know very well, this is nucleus, so electrons are present in these shells. Here if number of shells increases, then what will happen? The electron present in this shell, they have some nuclear effect also. This nuclear is going to attract, this nucleus has positive charge, so it is going to attract the electrons. But here these inner cells also have negative charge on it, and its shell also electrons are present there. So they form a shield, they form a layer, because they repel, negative charge will repel each other. So they decrease the nucleus effect on the electron present in outermost shell. They decrease the effect of the nucleus on the electrons which are present in outermost shell. It is clear to you or not? Okay, so this, because they form a shield, so this effect is known as the shielding effect or screening effect. Or screening effect. It is clear to you or not? What will be the order for the screening effect? Again, this will be the order for screening effect. So here, Z effective. Z effective is equal to Z. Z means the actual atom, the actual nuclear charge. The actual nuclear charge. And minus S. S means the screening constant or shielding constant. Okay, means what is the effect of this shield which inner cells are producing on the outermost shell? Because they are decreasing the effect of the nucleus on the electron present in outermost cell, and this effect of the inner cells on outermost cells is known as the screening effect. And what is the formula for this? This is Z effective. Now, which charge of the nucleus is affecting now the outermost electron? That is known as the Z effective. So, Z effective is Z. Z, what is the Z? Z is the atomic, sorry, here Z is the actual nuclear charge. Z is the actual nuclear charge. And S is the screening constant. And what will be the order for the screening effect? It will be the order. Any doubt in this? Okay. Then, electronic configuration. Elements having half-filled and fully filled orbitals are stable. So, if we will try to remove an electron from these orbitals, then it will make them less stable. Hence, more amount of energy is required to remove an electron from these orbitals. Means if half-filled orbitals you know very well, half-filled orbitals and completely filled orbitals. The elements which have half-filled orbitals and completely filled orbitals are more stable. If elements will be already more stable, so why they will remove the electron? They will not remove the electron. Okay, so if we want to remove the electron from the stable species, so we need to give more amount of the energy for removal of the electron. So if there are the elements which have either half-filled orbitals or completely filled orbitals, then they are the more stable. So they require more amount of energy to break the electrons, to remove the electron from outermost shell. We will focus on all these three factors: penetration effect, screening effect, and electronic configuration. Then we will see the trend of the ionization enthalpy. What will be the ionization enthalpy in group and period? Okay. Before that, I want to tell that what do you mean by successive ionization enthalpy? Successive ionization enthalpy. Successive ionization enthalpy, students, for example, if we have aluminium, atomic number is 13, so configuration is 283. First, I want to remove one electron from outermost shell. So, I will provide the amount of energy let us consider it is IE1, means ionization enthalpy for removal of the first electron from outermost shell. So after removing one electron, it will convert into Al plus, okay, plus one electron. Now I want to remove one more electron. So here it is present in form of Al plus. Now what is configuration for this? 2, 8, 2, because one electron it has already removed. So Al plus 2, 8, 2. Further I want to remove one more electron from outermost shell. So again I need to provide some amount of energy. So for second energy, let us consider this is the ionization enthalpy second. Second ionization enthalpy, IE2. Then one more positive charge will attained by this. Now it convert into Al2 positive. It is removing one electron further. Now it has removed one more electron. So configuration is 2, 8, 1. Further it want to remove electron from this because it is also not stable. Its octet is not completed till now. So further it will remove one more electron. So I need to provide some more amount of energy. Let us consider it is the third ionization enthalpy, IE3. Then it will convert into Al3 plus. Now its configuration is 2, 8 because it has removed one electron. Clear or not? So students, here this is the first ionization enthalpy. The energy which is required for removal of the first electron. This is the second ionization enthalpy which is required for removal of second electron. And third ionization enthalpy is required for the removal of the third electron. Okay. So these are known as the successive ionization enthalpy. So what will be the order for the successive ionization enthalpy? So this amount of energy will be the greatest, IE3, then IE2, and then IE1. Means this amount of the energy which is required for removal the third electron, it will be the maximum. Then IE2 and then IE1. Why it is? You can see here aluminum atomic number is 13, means electrons are 13. Protons are also 13 here. So it can remove here one electron is holding one proton. Okay. Sorry, one proton is holding one electron here. But after removing one electron, it is converting into the Al plus. So here protons are 13 because it is removing only electron. Protons are same. So protons are 13, but electrons are 12. And you know very well, size of the cation is smaller than the size of the element. So here size is going to be small. And if size decreases, then ionization enthalpy will increases. Why it is? Because here 13 protons can hold the 12 electrons more tightly. So we need to give more amount of energy to release the electron. Okay. Again, this size further in case of Al2 plus. Here electrons are how many electrons? 11. But protons are 13. So again size is going to decrease. If size is going to decreases, then ionization enthalpy will increase. So third ionization enthalpy will be maximum and first ionization enthalpy will be minimum. And this is known as the successive ionization enthalpy. It is clear to you or not? Yes. So student, trend in the periodic table across a period. While moving left to right in a period, the atomic radius decreases. So if size of an atom decreases, then attractive force between the nucleus and the outermost electron increases, due to which across a period, the periodic ionization energy generally increases. You have already discussed about the atomic size. Students, atomic size and ionization enthalpy, they are inversely proportional to each other. They are inversely proportional. If atomic size increases, then ionization enthalpy decreases. If atomic size decreases, then ionization enthalpy increases. They are reciprocal. Why? Because atomic size, if atomic size will decreases, means force of attraction is going to increase. Force of attraction is going to increase, because if size is decreases, means particles are coming closer. Particles are closer to each other. If particles are closer to each other, means their attraction is high. If they have highly attractive force, then size will be decreases. Okay, so you know very well, if we move from left to right in a period, so atomic size decreases. Atomic size decreases. Why it decreases? Due to increase in the nuclear charge. It is decreases due to increase in the nuclear charge. If it is going to decrease, then ionization enthalpy generally will increase when we move from left to right in a period. It is clear? Then in the second period, there is a discrepancy in the trend of the ionization enthalpy from boron to beryllium. What do you mean by this? You know very well, if I talk about the second period, so elements are lithium, beryllium, then boron, carbon, nitrogen, oxygen, fluorine and neon. Students, if I move from left to right, so atomic size decreases. Atomic size decreases. So ionization enthalpy should be increases. But here, ionization enthalpy for beryllium is greater than boron. Beryllium is greater than boron. It is exception. And here ionization enthalpy for nitrogen is greater than oxygen. Why it is? Due to its configuration. So here beryllium atomic number is 4. So here configuration 1s2, 2s2. And for boron, here atomic number is 5. Configuration 1s2, 2s2 and 2p1. So here s orbital is completely filled orbital. S orbital is the completely filled orbital. And you know very well, the element which have completely filled orbital are more stable. So it is more stable. So we need to give more amount of energy to remove the electron from this. And here, this is not completely filled, it is partially filled. So one is the electronic configuration, and second factor is penetration effect. We can also see here, s orbital, it show the more penetration effect as compared to the p. So it has more penetration effect. Due to more penetration effect, its size is, it will require more amount of the energy because it is extra stable due to its configuration. It is clear to you or not? Further, you can see in case of the nitrogen. Nitrogen, what is the atomic number? 7. So 1s2, 2s2, 2p3. But in case of the oxygen, here it is 1s2, 2s2 and 2p4. Again here, p orbital is the half-filled p orbital. Half-filled, and half-filled configuration is more stable. So it is more stable. So we need to give more amount of energy to remove electron from this. It is clear to you or not? So these are the exceptions. And if you move in a group, you know very well, in group atomic size increases. Atomic size increases when we move from top to bottom. Why it is? Because down the group number of cells increases. Number of cell increases. You know very well, atomic size and ionization radius are reciprocal. Sorry, ionization enthalpy are the reciprocal. So if atomic size is increases, then ionization enthalpy will decreases down the group. Ionization enthalpy decreases. So students, this is all about the ionization enthalpy. Do you have any doubt?
No, ma'am.
No. Okay. So thank you. Have a nice day. Second